Hello, Lena. Welcome to Module 2. And we are considering topic 2 under the topic sequences and series. This is your mathematics teacher, Mr. Chims. And we're going to look at this topic in details. So, sequences and series. Sequences and series, like I said when I was introducing the topics, this is a topic that comes in both paper 1 and paper 2. So we're going to begin with the paper 1 part of it. Now, before we begin, we need to know what a sequence is. Okay, we need to know what a sequence is. So when you talk about a sequence is basically a set. Okay, a sequence is a set of ordered numbers. Sequence is a set of ordered numbers where a pattern exists. So basically that's the definition of a sequence, a set of ordered numbers where a pattern exists. E.g., so an example of a sequence can be 2, 4, 6, 8, and so on and so forth. So this is a sequence. If you look at this sequence, the numbers are in order. Not only are they in order, they are following a certain pattern. So there is a pattern that is being followed here, such that you can even predict the next term. Another example I can give is, let's say 1, 2, 3, 4, and so on and so forth. So all that is an example of a sequence. So to begin with, we are going to go into details and we're going to talk about arithmetic progression. We are going to look at arithmetic progression, which is usually abbreviated as AP. Okay, so we're going to look at arithmetic progression, also known as AP. So what is an arithmetic progression? An arithmetic progression is a sequence. Arithmetic progression is a sequence where the next term is found, okay? Found or formed. The next term is found, or you can use the word formed, by adding a constant amount to the previous term. So an arithmetic progression, or AP, is simply a sequence where the next term is formed by adding a constant amount to the previous term. So when you talk about an AP, we are looking at an example like, let's say 1, 3, 5, 7, 9. So this is an example of an AP. As you can see from the previous number, which is 1, for them to arrive at 3, there was an addition of 2. So here there was an addition of 2. Again, here there's an addition of 2, addition of 2, addition of 2, addition of 2, just like that. So this is an example of an arithmetic progression. So now in this example, these 2, okay, these 2 that we are adding, this is the constant amount that I've talked about in the definition, or the constant number that is being added to the previous number. So there is a term that we use to refer to this constant number. This constant number is known as the common difference. So this is known as the common difference, and it is denoted by the letter D. So this is the common difference, the term that you are adding to the previous amount in order to get to the next term. So if we add if we add 2 to 9, we are going to land on 11, just like that. So what are we using? We are using the constant amount, which is plus 2, plus 2, plus 2, to arrive at the next term. Okay, so to arrive at the next term. So basically, this is what you need to know about the definition, and this 2 is known as the the common difference, like I said. Then this number here is 1. We refer to it as the first term. This is the second term, so this is the third, 4th, 5th, 6th, 7th, and so on and so forth. So these are simply some of the terms that you need to know. So we refer to these as first term, second term, third term, but the first term has a special symbol that we use. So if you want to denote the first term, we use the variable a. So the first term is denoted by a. Okay, so the first term is denoted by a, then the common difference is denoted by d. Now, allow me to give you a few examples on arithmetic progression. Okay,